Hi all. In this video, I'm going to talk about wind action or wind load. So to start with, you should go to New Zealand Standard website to download the wind action part 2 of ASNZS 1170.2. So if you open the standard and read through it, you will find a lot of information. And generally, wind load is a bit more complicated than other loadings. So what I've done, I simplified the process and the stages, so you don't need to be too worried about different loadings for the wind load. So if you open the handout for the wind load, you will see that I put all the factors that you need for the wind load, and this document is pretty much straightforward. So here is the main formula to calculate the pressure of the wind load. So P is the design wind pressure in Pascal. So it's if you just follow this document, it will be just reading from the tables. It's not many calculations involved. So you find different factors from the tables, and at the end, you just multiply them together to get, again, the factors that you would need for this main formula. So for this main formula, as you can see, we need rho air, which is the density of air, and is given as 1.2 kilogram per meter cube. So you just put 1.2 here. And V ds theta is the building orthogonal and design wind speed. Usually theta is 0, 90, 180, and 270, given by clause 2.3. So if you go to that clause of standard, you will see how to define this factor. And then we have a CFIG and CDyn. So CFIG will be an aerodynamic shape factor, and it's defined in section 5. And CDyn, it's a dynamic response factor as given in section 6. So as you can see, if you look at this part, you would need CPI, KCI, and you multiply them together to find the CFIG I, and also you need these factors to find CFIG E, and then you need this CF, KA, and KC. So as you can see, these are just a lot of factors that you need to find from the tables and based on the information in the instructions. And sometimes you need to just assume something because you may not have the exact information for your project. You just assume something. to be able to define these factors. So step one is to find the region that your structure or building is located on. So as you can see, your project is in Hamilton. So that would be region A7. So these are the boundaries between different regions. So this part of New Zealand is called the region A7. So if you scroll down, you will see step two, find the regional wind speed VR. So it is based on the return, we call it it depends on the design that you have. For example, if it is a very important building, you may go for designing the building for the wind load that happens every decade, every 1,000 years. But for normal building, we may just consider V100, which means the velocity of the wind, which happens every 100 years, every century, okay? Or maybe the building is very ordinary, or it's not very sensitive to wind, so you don't need to design it for example, stronger wind. You just need to design it for a wind which happens every 10 years, which is as you can see, if you compare the velocity of that wind, you will see, for example, for A1 to 7, the average is A7, right? So if you compare the wind that happens every 10 years, the velocity is 34. And the wind that happens every 100 years, the velocity or VR is 41, and the wind which happens every 1,000 years, the wind velocity is 46. So you just from this table, and based on your design, you just choose one of these. So if in the instruction it didn't mention anything, you just do a bit of research and see, usually, for example, for food processing, warehouse, how, for example, how strong the wind is considered. For example, are you designing it for a wind load which happens every 100 years, or you design it for a wind that happens every 20 years? So based on some assumptions and some research, you can choose which velocity for the regional speed you want to choose. Step 3, it's the find wind direction multiplier. So what you need to do is to find out, for example, in that you know the exact location of the building that you are designing it, so you can do some research and find out about the direction, the dominant direction of the wind. So if it is in South Hamilton, just see what is the dominant direction of the wind. Is the wind dominantly like blow from east to west, from south to north, or from southeast to northwest? So you need to do some research and and also some assumptions to find out about the direction that you need to consider for your wind. As you can see, all of the numbers in this table are equal or below 1. So if in case that you don't have any information for that region that you're designing a building for, you can just consider MD as a 1 because it's the maximum number that you can find in the building, in the table. So it would be safe to choose 1 over like 0.8. Step 4 is to find a terrain or height multiplier, which is MZ cat. So as you can see, this table is for terrain or height multiplier for gust wind speeds in fully developed terrain, all regions. So as you can see, it depends on the height of your building. So based on the height that you chose, so for wind load, if I want to draw here. So if you consider this is your building, the height, which is Z, is calculated from the base, which is on top of the floor. So here is a ground. I say G, ground. And then from the middle of your roof, if your roof is not flat, you need to consider the average of the roof. So this height gives you the Z that you need for reading this table. So for example, let's say you consider this height of your building is like 10. And you need the height of your truss that you also choose yourself. For example, let's say 2 meters. So the total height is 12. But here, if you consider the middle of the roof to the ground will be 11 meters. So what you need to do to, you need to interpolate between these two values because you don't have 11 in the table. So you read the number for 10, you read the number for 15, and you just interpolate between these two. The other thing is terrain. So we have terrain category 1, 2, 3, 4. So if you scroll down, you will see the definitions for different terrain categories. So again, you need to do some research about that area that your building is located in, and also maybe some assumptions. So if you look at the Google map, you may find out if there are many buildings around that area or there is none, or so it is what terrain it is located on. So you need to do some research, and with some supporting information in your report, you will choose one of these terrain to read this table. So for example, you say it's very exposed, open terrain with few or no obstructions and enclosed. So what I'm gonna do, I choose terrain category 1 because based on a satellite picture, I found that is the case, you know? So you just read through this terrain and see which one is more appropriate for your case. Let me erase this one. Okay. Next step is to find the shielding multiplier. So from the name, as you can see, shielding would be based on, for example, what other buildings or mountains around your building or structures that doesn't let wind to come through to blow on your building directly. So again, you need to find out about this factor by research, or alternatively, and you can choose one. The other factor is topographic multiplier. Again, it depends on the topography around the region that you're building your structure. You can choose the topographic multiplier. But this part has some calculation and it's a bit too complicated. So what I suggest is just ignore the whole calculation and just assume MT as 1. So it's a bonus. You don't need to be worried about calculating the topographic multiplier. And then we need to find CPI. I here stands for internal. So as you can see, we have table 5.1 and 5.1a and 5.1b to find internal pressure coefficient CPI. Again, you need to have a look and see which one of these explanation is true for your building. So for example, if all walls equally permeable for your building, that would be the factor CPI is minus 0.3 or 0. If you have this case, for example, it said this or that, it means you have to calculate for both of them separately. So you analyze and design your structure for minus 0.3, and once more you calculate and analyze it for 0 and see which case will be critical, or it applies more load or pressure on your building. Okay. So for CPE, which is the external pressure coefficient, you need to find out first the direction of your wind. For example, if here is the building you're designing for, and the wind is blowing in this direction, this wall is a wind wall, and the opposite one is leeward wall, and this one and the other one will be side walls, and the roof is our roof. However, if the wind is blowing in this direction, the wall that is exposed to the wind is wind wall, and the opposite direction is lee wall, And these two are side walls, and the roof is up and downward, okay? So for different scenarios, just look at the graph or the picture that is provided here, and then you would know for which part of or which wall of your building you need to apply how much coefficient. So as you can see, B and D is also defined based on the direction of the wind. So if the wind is blowing in this direction, B shows the width of windward wall. However, if it is blowing in the other direction, B is this dimension. Again, it is the windward wall width. So just for each scenario, just have a look at these buildings and make sure that you're choosing the right number for each wall. So here, define W stands for windward wall, S side, L leeward wall, U upwind slope, and R is crosswind roof slope, D is downwind roof slope, and H is the average roof height. Again, it shows here that I told you. The height will be calculated from the ground to the middle of your roof if the roof is not flat. Then you can come to these tables. For example, for walls, which are windward walls, you read the factor from this table. For walls which are leeward walls, you choose the number from this table. And for side walls, you choose from this table. As you can see, here is the horizontal distance from windward wall edge. So the definition for this part is a bit, I need to explain it. So if you consider here is your building, here is the height from the middle of the roof to the ground, which is H, and the width of your building is something like if we consider this is the direction of the wind, so it is a windward wall, and this is B. So what it says here, horizontal distance from windward edge. So from this edge, because you're finding a coefficient for the side walls, right? So here is a side wall. So what you need to know is what is the distance of that part of the sidewall from the edge of windward wall. So what you need to do, it depends on the height. So from 0, which is here, to H, so you go to H. So this part of your sidewall gets minus 0.65, minus 0.65. And from H to 2H, again, it is sidewall, but here from H to 2H, So here is 2H. So this part of your wall, the coefficient will be 0.5 minus 0.5. Okay. When we say minus, it means it's this direction, outside direction. Okay. So the wind, when the wind blows in this direction, the side walls, the load which applies on the side walls are in a way that they are sucking out the wall. So the direction of the load, wind load will be in that direction. Okay. And for the roofs, again, as you can see, it depends on if it is a gable roof and the alpha, which is the angle of your roof, is less than 10%, sorry, less than 10 degree or more than 10 degree, the coefficient is different. So here it said for upwind slope, which is U, and for downwind slope, which is D, and for R, which is the gable roof, you can find them here. And other tables again for downwind slope, and that's it. So my suggestion is to give it a try and see how it goes. So when you find the coefficients, you will be able to go back and use the main formula to calculate the other factors, and at the end you can calculate the pressure. Okay. So if there is something that is not provided in this document and you need it, for example, if I mention clause something or section 6, section 5, you can always open the standard and read through that part. And if you have any question, just get back to me or we discuss it in the class. Thank you for watching this and see you in the next video.